Welcome to the show. My name is Bret. This is my live streaming channel, and I'm here every Thursday. So, in case you're new, like and subscribe, do all those social things to help me out. And then you're also maybe interested in supporting this show. Maybe you get your questions answered today, and you appreciate all the time I spend on the internet talking about containers and Docker and Kubernetes and DevOps and all those things. So you can click some links below to find me on all the socials, including my Patreon. And those of you that are patrons, I appreciate you so much. You're really the best of the people supporting this show. There's lots of you that are in chat every day, and obviously I appreciate you as well. But those that support this is really, that's how this show keeps running. That's how I can pay the other parts of my team that actually work on this stuff and get the podcast back up and running, like we'll talk about in a minute. because that's a thing that just happened. So if you haven't heard, I have a Patreon page, and this is basically the only or best way to find out what I'm creating, what's coming up on this show and the podcast, new guests, when are new open source repos getting launched, when do I have major course updates, like all those things are there. Maybe one email a week. So go check that out. This is patreon.com/Bret Fisher. You don't have to give me money, but if you'd like to support this show and the podcast and the other open source efforts, please consider it. And thank you to all of you. You don't have to actually pay there. You can just click follow, and then you can sign up. You get app notifications, emails, whatever, when I'm doing stuff. I think that's a little bit less effort than my newsletter, which we had, but I just ran out of time. I couldn't do all the things. So we kind of stopped doing the newsletter for a while. And then, of course, if you're not into Twitter, where I announce all the things as well, this is less traffic, less noise, all focused on the good stuff. So go check that out. So today's show is all about the Udemy courses, but it's not just about coursework and course stuff. So I always invite once a month everyone out of the courses to come on the show. I have no guests, or if I did, they would only be here to answer your questions. And it's about all the things you're learning and about the things you're doing in your jobs or in your hobbies that are container related. By the way, I just realized the little buttons up here are not showing up. So these little things should be there. All right, so you can get to this show every week with Bret.live, same time on Thursdays. Over there, the DevOps.fan, that is our Discord server. We just passed 6,000 people on that server, and every day we're on there talking containers. It's free. It's Discord, so it's a little less businessy than Slack or some other business tool, a little bit more fun. And then for those that are high-fiving patrons, we do a once a month luncheon, not really a lunch and learn, but more like a hangout where we all just get on Discord in a video room and we just talk about what we're working on, our hobbies, usually we get into some container topics. We had one this week where we talked about some ideas around keeping things fresh, keeping your images fresh and keeping your servers fresh and not stale or old or outdated or anything like that. So we're going to talk about that because I actually have a tab that in my browser here just to remind me I want to talk about that and some ideas I have for you around maybe the gold standard for how you should treat your images and your infrastructure. All right. What else? I got some other news. We're going to talk about Kubernetes 122 that came out, a new security guidance white paper from several U.S. government organizations, including the NSA, which writes good stuff. And then some common questions that I get that is in my AMA. And if you don't know about my AMA, we're going to talk about that too. I have a GitHub-based Ask Me Anything so that if it's not, if it's a course thing, then you ask in the course Q&A, and my team and I of teacher assistants will try to answer your technical questions about the course. But if you're just kind of out there in the world working on containers and you have questions about implementation, design, features, stuff like that, I run an AMA on GitHub. So we're also going to talk about that. But let's get started. I'm going to run through and say hello to everyone and see if we have any initial questions. By the way, thanks everyone for showing up. I know that you all got a busy life and that it's hard to be on the internet all at the same time, but I appreciate you showing up here from all over the world, all of the continents, except for maybe Antarctica. All right, so the first thing up, and feel free to ask questions anytime. I'll keep checking the chat throughout the hour. This is a tweet I put up a couple days ago, and it was based on the patron high fivers. That's the $5 a month club, where once a month we get on a Zoom and we talk for an hour, maybe 2 hours about DevOps things. And I'm posting that into the chat. But on projects that I work with, clients I work with, and students that eventually deploy containers in their companies, I tend to run across the same problems with things getting stale. And so I tried to come up with a tweet that would be if you're a DevOps focused person, what are the 3 things that you need to worry about in what we all call day 2 ops? So most of my courses are teaching you day 1. They're teaching you the basic beginnings of containers and Kubernetes and how do you make them and how do you deploy them, maybe how you do a rolling update. Rolling updates would be day 2. But day 1 is all about the greenfield fresh install. You're doing things for the first time. That's a part of everyone's learning process. And when you first implement a tool, that would be day 1. But then the rest of your life and the rest of that resource's life is day 2. So doing updates, doing patches, doing, rebuilds of things to keep patches current. And those are all day 2 ops. And day 2 ops are notoriously difficult. They're always more complicated than you can do in a blog post or in a 5-minute video. And one of the things I see is that we all naturally tend to design for day 1. We build container images not thinking that we're going to have to rebuild them 10 times a day in an automated fashion. But that's the reality. If you're doing this for a living, you will be doing that. And you want to automate as much of this as possible. So I put this up here as the top 3 things of if you keep this in mind when you're designing your images or how your continuous integration will rebuild your images, or maybe you're using Terraform to build your infrastructure. If you keep these 3 things in mind, hopefully that will help you make better decisions about your infrastructure. Because what I often see people will say is, well, I use Terraform to build my infrastructure. But the last time you ran that Terraform was a year ago because you built the servers or you built the settings or whatever you did with your Terraform, and you didn't need to ever update it because nothing's changed yet. But how do you know that Terraform still works? How do you know that things haven't drifted over time because someone changed something somewhere else, right? So we need to start thinking about not just doing things the first time, but how we repeatedly do those things and how we keep them current and working. And so these are the 3 areas that I see problems, right? These are the big 3 DevOps sort of over time growing problems for teams is they might be using an old version of Postgres, and that's fine, right? If you're using Postgres 9, that's fine. But the image from Postgres 9 has probably not been rebuilt on Docker Hub in a long, long time. And this is sort of where the official images become a problem. And I wish we had an industry-wide fix for this, where images, if you're not using the absolute latest of that image, then all the dependencies inside that image get stale. Not because they have to be stale. They could be totally current. But because the Docker Hub official images aren't continually rebuilding old versions of software with updated dependencies, because that's not happening. At least I don't know of any images that do this. What that means is if you're using Node.js 10, your stuff's really old. Not Node itself, but the things that Node depends on, the dependencies, or Postgres, or Ruby, or pick any official image. If you're not using the latest release, they almost always won't rebuild that image. So that image for that version of Ruby 2.8 or whatever from 3 years ago, granted, you might be fixed to that version of Ruby, but Ruby depends on a bunch of other things to be there. OpenSSL, for example, has to be there. But those images aren't getting rebuilt with new updated OpenSSL. And that's a real problem when you start to go security scanning. So let me show what I'm talking about. Like this maybe isn't obvious to everyone, but it's as we all now have images that are years old, because Docker is now getting old, this problem becomes more obvious. So let's look at Postgres. So this is Postgres, right? If I scroll down, the latest versions are in the 13 range, but most people I know are not using Postgres 13. They're probably penning, to something like Postgres 10. All right, so here's part of the problem with this. So if I go to 10, And Buster is the underlying Debian version. So we've got an older version of Debian here, Stretch, and then Buster, which is the current version 10 technically. And this is the Docker file, right? And you can see that it's coming from Debian Buster Slim. But we don't know which version of that. We don't know when that image there is built. So the thing we have to do here is we have to start going and looking at the tags. And then maybe I'll look for 10 dot, okay, so it seems to me that maybe 10.18 is the latest, right? So the nice thing here is you can see this was built 2 days ago. So that's a good image, right? Good on them for rebuilding that. But what if I'm still on version 10.17? And it's Buster, not Alpine. So see how that says pushed a month ago? But what if we deployed, version 16? Oop. So it looks like, version 10.16, 3 months ago. All right, so you start to see the problem here is that maybe my team has standardized on a major minor version of something. But that doesn't mean the dependencies inside that container need to be old. They should be fresh. They should be updated at least monthly. Now, the version of the app I'm running in there may be hard-coded, and maybe I only update it for patching, right? So that would be, if this is Simver, it would be 10.16.2 or 10.16.3, whatever. Right, and this problem is all across the board. So if I went to a Ruby image, Ruby would have the same problem. So we can see, 3 just came out recently, so that's probably too new for most people. But a lot of people might be on 2.6, right? So if I go to 2.6, and the 2.6.8 was pushed a day ago. But what if I'm on 2.6.6? So that was only built 5 months ago. Even though all the dependencies probably have a ton of vulnerabilities in them at this point because it's half a month or half a year old almost. So if I went and scanned these, I'd probably get tons of scanning vulnerabilities, CVEs. And that's not because Ruby 2.6.6 has tons of CVEs. It might have a few, and that's maybe why they updated to 2.6.8. But here's part of the problem, right? Is even if I standardized on 2.6, one of the problems here is that as versions start falling out of support, because maybe Ruby or Java or whatever only maintains the last 3 versions, you might still be forced to use an old version of the app. But it doesn't mean you want all the dependencies to still be old. So if I go back to 2.5, see, okay, now we're 2 months old. If I'm still on 2.4, granted, 2.4 is maybe not under official Ruby support, but a lot of teams can't keep their apps up to date. But that's okay. We're DevOps people. We will patch all the stuff underneath, right? Which is what we were all doing before containers. If you look back before we had containers, you would have old apps on servers, right? But then there was probably a server admin that was doing apt updates and yum updates on a monthly basis. And maybe because you were pinning to a specific version of Ruby, it would not change that version. It would stick to 2.4 or whatever you were using. But all the other things, OpenSSL, if you were using Apache or something, like all these other things that weren't being pinned would get updates. And that would keep your server more protected. So the problem here is that official images, unless you're always running the latest, most up-to-date version, can't be depended upon for the latest dependencies. And that's a real problem. So interestingly, this week in our chat, I don't know if Biker is on today, but Biker presented the standard of what if all your images, when you're going business production, all your images are now built from Ubuntu and you manually install with apt, you're doing a manual apt install or building from source, everything you're building in there. And then once a month, you're going and getting the newest version of Ubuntu and changing your from to do that. And then everything else, whether it's Postgres or Ruby or Node or whatever, you're adding those on after the fact. What that does is that ensures that you always have the latest Ubuntu patches and the latest fixes in that container. One of the things that I like about Ubuntu is if you go to Hub, actually we'll just go in here. If you go to Ubuntu, it tends to get security updates faster than Debian. It's also really small now. Like it used to be 150 meg, but it's now, I think it's like 50 or 60 meg now. It's really small. So it's not that big. If you've been on here before, you've heard my opinions about Alpine. Alpine is its own thing, and everybody doesn't need to be forced to go to Alpine. And it's not without a large set of issues in containers that I continually have problems with customers fighting Alpine. So a lot of times we just don't go to Alpine because there's not as, the benefits are outweighed by the negatives of Alpine. So if you'll notice here, one of the things I love is that they give you date-based tags. So instantly I know if I'm going to use 2004, which is the latest long-term supported release, I can know exactly when that was built. And I might even be able to go find a more recent build if they rebuild these. So anyway, that was my thought. Let's get to some questions about this. See if anybody's got some questions. Is it possible, Papoon says, hopefully I pronounced that name close to correct. Is it possible to scan custom Docker images for vulnerabilities? How? Yes, absolutely. It's now built into the Docker command line. If you just type Docker scan in your command line, it will in the background use Sneak to scan those images. A lot of image registries will also scan when you upload them, like Harbor or Docker Hub. If you pay for Docker Hub, you can have it scan them. Harbor, which is a free registry, can also integrate with scanners like Trivy. Trivy is one of my favorite open source scanners. And made by Aquasec. So we got Trivy right here. I'll put that in chat. Hey, Biker. So yeah, so Biker and I were talking about this week and just talking about, a standard for building all your images from a single upstream image that's always refreshed, always up to date. It means more work for your team because now you got to install all the things. You can't just use Ruby or Postgres or whatever, but it also does mean that you're going to have less vulnerabilities in your images. And I think we're all going to be fighting as we get better and better at scanning images and making standards for our security and making standards for our Kubernetes clusters. And we're going to say you can't have any high or severe vulnerabilities in your images. We will not allow you to run them. That's going to be a real problem with old images because they're going to have some of those. So you're going to have to come up with these new ways to fix your images. And if you're coming from a broken, out-of-date upstream image, it's not really a way to fix that unless you update that image, right? So you can do that there. You can do it at the command line just by typing docker scan. And if you just type in an image name, it will automatically download that image, or if you have it locally, it'll scan that image. And then Docker will use Sneak in the background, which it comes bundled. If you're using Docker Desktop, it comes bundled with Sneak. And it will use that to scan it. So yeah, so that Python 3.5, which is pretty old, it's a couple years old. And it's got 12 issues, 1 critical, 1 here. See, so you get that nice, easy interface right in Docker. But there's lots of other tools out there. You can use Trivy to do the same thing. You can download that or install that. Yeah, I was going to say my audio seems fine. I can see it going through the internet streams. All right, let me see if there's any other questions on this. I thought containers were supposed to solve the dependency problem. I'm not sure what you mean by that. It doesn't necessarily make dependencies irrelevant, and it's not going to auto update your dependencies. That's the job of your app and you setting the dependencies in a Docker file. So Docker doesn't know anything about dependencies. It just knows that what you put in the image is what it's going to run on the server. So your image is only going to be as good as what you type in the Docker file. Now, what Docker does solve with dependencies is it ensures that those same dependencies are exactly what it runs everywhere. That's what it's solving, is it's build once, run everywhere, and run the same thing everywhere, right? The same thing that's running on your machine is the same thing running on the server. That's what it's solving. But it's kind of that whole garbage in, garbage out. So if you make a bad Docker file that has outdated dependencies, then that's what's going to run on the server. Now, it's not going to change them because Docker doesn't really understand npm or apt or any of the other things. It's just running commands. And it's not going to warn you if you run bad commands or, unsafe commands inside of images. So when you, if you look at I think my DockerCon 2019 talk, I think in that, I talk about the best practice of dependencies and how you want to pin those. So you always want to pin all your dependencies as much as you can. So yeah, and you do that differently for every package manager, right? So, all right, let me scroll back up to some of these questions. Yeah, Biker's pointing out container image is the guy sitting inside the time machine zipping into the future. As the world changes around him, he is the same. I'm a sucker for any time travel movie, so any time traveling reference you can make, I will applaud you. All right. So let me scroll back up here. What do you say about Swarm and its current status? Do you still recommend it for small clusters? I think it's still a great tool to get started and play with it yourself. I don't see any businesses continuing to deploy more Swarm or installing Swarm at all. It's multiple reasons. Swarm is still getting some updates. There's actually an update coming. There's a big set of PRs that Mirantis was working on and still working on to add storage support for CSI, which is the way that Kubernetes uses storage. So it's still there. It still is in Docker. However, Docker no longer has a team building it. They will still merge in patches and stuff like that if anyone else makes them. But at this point, Kubernetes ecosystem has so many solutions and so many tools, and then every cloud now provides you Kubernetes out of the box, and it's all super easy to get started in comparison to what Kubernetes was 3 or 4 years ago, where it was a lot of your own work and your manual setting up of clusters, whereas now, it's a couple of buttons to set it up in the cloud, and we now have easier tooling for each cloud vendor to create Kubernetes clusters. You have things like Fargate and Autopilot on Google and Fargate on AWS for making it even easier, where you don't have to deal with any nodes or updating of nodes, which is something I really like. I don't want us to have to spend time on managing infrastructure if we don't have to. So I think a lot of the reasons to not try Kubernetes first are gone. So I think eventually I may pull Swarm out of my course and maybe just keep it as a separate course, but not in the Docker course itself. But a lot of people still like to use it for personal projects. I still use it I have a couple of APIs that run on the internet, and I have a 3-node Swarm cluster in DigitalOcean, and it's been working for 4 years. I update it, I patch it, but it sits there and it works and it does fine. I don't have advanced needs for it. So I don't need all the things that Kubernetes has. However, if you're a business and your business relies on this infrastructure for money, it makes its money on that infrastructure, you're probably going to need to migrate to Kubernetes, because either the business is going to need things that you can't do in Swarm easily, and and those tools probably exist in Kubernetes because there's thousands of tools now for Kubernetes to do everything, and Swarm there isn't. So you'd have to either build them yourself or create them from scratch, kind of thing. So that's the unfortunate world with Swarm. So it's not a matter of you can't use it or it's no longer supported or whatever. It's just it's probably not the first choice anymore, right? But, you know, you learn it in a couple of hours in my course. It's not that much work. And then you move on to Kubernetes, and it's nice to know that it's existing, but it's probably not something you're going to use a lot. Hopefully that helps. I don't recommend Swarm anymore for my business customers simply because even if they only have one person, there's probably an easier way for them to run like Kubernetes with AWS's Fargate solution or Google Cloud's Autopilot, so that they don't have to manage the infrastructure at all, but they can still create manifests and Helm charts and stuff like that for their app and deploy those apps and not have to worry so much about all the stuff to do, right? They can have the manifests or the customize or the Helm or whatever. And yeah, you're still going to have Docker Compose for local use. And then you're going to have the production stuff in your Kubernetes manifests. And that's it. In a microservice system, what are the better practices to implement it? So I am not an instructor for microservices. So microservices aren't necessarily a yes/no decision. And I don't really even advocate microservices in a lot of scenarios because you could argue all day long about what is and isn't a microservice. And so what I see a lot of people doing is making smaller services. Mini, not micro, but mini services, you know, or just splitting out parts of your app and distributing it more. That's the trend. But going all in on microservices is not something I see very many people doing, simply because they've got lots of existing infrastructure, lots of existing apps that are not microservice. And microservices comes with its own set of problems. If you enforce it on everything and everything has to be a microservice, you're now just as dogmatic as everything has to be a monolith, right? You don't want to be that rigid. So I tend to find teams that will say, you know what? I got this little thing that makes a PDF. It makes a PDF report for my web app. I'm going to make that a microservice. And then I'm going to use Redis as a queue to offload the work so that my web app no longer has to make the PDFs for some report download, right? So that might be considered a microservice, but it's just for that one thing. Not everything has to be a microservice. But I don't teach programming languages, so I'm not going to sit here and tell you how you should design your application infrastructure. But what I do see is that teams just stay flexible, right? Maybe this one deserves a little bit more of a monolith app, and maybe that one is a true microservice, or maybe this one's a little bit of both. It's maybe not as big as a traditional app, but it's not also, it's got, you know, many different endpoints, but it's not micro, right? Let's see. What else we got? Yeah, Michael's saying use AWS ECR for scanning. Most of the container registries now have scanning, so yeah. Speaking of vulnerabilities, are there better host distros to use than others? I've heard of Fedora CoreOS and Red Hat OpenShift. Well, Red Hat OpenShift is not an OS. It is a distribution of Kubernetes. CoreOS is deprecated, no longer used. I would say my opinion on this varies. The context, I'm very sensitive to context on telling you what your host OS needs to use. I have always used Ubuntu, not always, but for the last decade or more, I've used Ubuntu and I've never regretted it. You use the long-term supported version if you want to play it safe. And that's what, when you start looking at things, that's what, for example, GitHub Actions run on Ubuntu. I recently learned this week that AWS's infrastructure now, I'm sorry, not AWS's, Azure's Kubernetes infrastructure now runs on Ubuntu, I think. So I think it's a safe choice. You don't have to pay for support if you don't want to get support from Ubuntu. And it doesn't require that you completely rewrite everything for a new OS, because if you go to a container OS, you're going to have to redo everything. All of your, all of the scripts or things you would run to update or refresh, those are all going to have to be rethought. And your whole design of how you deploy and update OSs is going to have to be rethought. And that's a lot of work. So I'm not going to be the one to tell you have to do that. I will tell you that none of the teams that I work with and any of my clients use container OSs, simply because they've got bigger problems on other things and other projects before they need to replace the OS, right? So as long as they're keeping that OS fresh and updating it consistently or replacing it, this is going back to my post from earlier, right? Anything with a server OS is ephemeral and rotated by above. You can do that with Ubuntu or Debian or anything, right? So if you're doing that already and you're replacing things instead of updating them, you're already ahead of the curve, and you're keeping this as secure as you can make it, right? Going and completely swapping that out for a brand new container OS that can work everywhere, because maybe you have some on-prem, maybe you have something in Azure, maybe you have something in AWS. Like, it's going to be hard to do that consistently, but Ubuntu runs everywhere. Everyone's got it, right? So that's how I approach it. Doesn't mean that you can't do something different. It's not that my way is right and yours is wrong, but I don't really force container OSs down people's throats, because I feel like it creates more problems for them and more work than we're really going to get out of the whole project. Now, if you're someone who's got thousands of servers and you're running entire data centers and you're constantly deploying new hardware and you've got a whole team to dedicate to that, then you probably should do that. If you're running a private cloud of hundreds of servers physically, then you probably should look into something like that. But for a lot of us, we're just using what the cloud provided, and maybe we've got a couple of racks somewhere, right? We don't have a ton of our own infrastructure that we need to manage the OS. I hope that helps. Let's see. I'm reading up on the chat. Okay. Let me show you some other things that happened recently. So you may have heard, if you're watching the internets, the NSA and other agencies all collaborated on a white paper for Kubernetes. And I encourage you to at least skim it and then just know that it exists, so that when you're implementing certain parts of your infrastructure, that you come back to this and just use it as a guide. Now, there are actually some scanners out there that will help you scan your Kubernetes clusters. Most of this, by the way, not all of it, but most of this is for people that implement clusters themselves. So this is maybe the cloud provider, which I'm sure is, all the major cloud providers are already following this kind of guidance. And if you're having to deploy your own clusters and set up your own control plane in Kubernetes, then you would want to follow this. But there's still stuff in here for those of us who are just using other people's infrastructure. For example, if I go down this guide to the table of contents, so this pod security stuff right here, this is all largely, not always, but largely up to you if you're writing manifests. If you're someone who has to write the manifest to run the pods, run your containers in those pods, you're going to want to check this part out, because one of the things that are in here is around making sure that the user in some of your containers doesn't run as the root user in container, and then also preventing, let's see, where it's at, somewhere in here, preventing escalations. So preventing your pods from being able to be privileged, right? And doing other things. This is not what I'm looking for, but this is a way to hard code your container to run as a specific user from Kubernetes. Probably shouldn't do this because it's probably going to break your image. You want to do this inside your image where you're using the user command with the Docker file. That's how you want to set it up. But most people don't realize that if you're using a programming language, and as far as I know, all of them have this: Node, Ruby, Java, .NET, you name it, they're all going to run your app as root in the container, which granted is not the same as root on the host, but they're going to run it as root in the container when they don't probably need to. So it's up to you to create that user in your Docker file using standard Linux commands, and then set the user to that new user account you created so that your app runs as a lower privileged user. Because most of the time your app, as long as the permissions are correct on your file system, your app won't need root. It's probably not installing software in the container on its own. You probably did that in the Docker file, right? So in the Docker file, you install the apt and the yums and the npms, you do all that, and then you set this user as root. Now it does make things more painful, especially when you're doing local development. So a lot of times in local development, I will hard code in my compose file to run as root so that I can do easier things in the container like change dependencies and reinstall them and stuff like that. But in all your testing, when you're building the image and then testing the image, always run that as the low privilege user that you set up in your Docker file. All right, so they're guiding you in here. And so that's up to you, right? That's the job of the Docker file and the Kubernetes manifest maintainer. So they talk about that stuff here, and they talk about image scanning and how that works. And there's pod security policies, which is kind of what I was talking about. And they have this list of the settings that you need to go look up inside your manifest. And for the example, this one, you should have it set to false so that the pod can't be privileged. You want to disable the ability for it to go do things in the host. And read-only file systems, by the way, most people can't, unless you're on a brand new modern application like maybe Golang or Rust. It's often hard to do read-only because apps love to store, especially web apps, right? They love to store temp files and other things while they're running, and that'll be hard. Unless you can get fancy enough to make volumes and use tempfs and stuff like that. But that's more advanced. But once you get there, read-only file system makes it really hard for that container to do things, especially when they're not root user. So if they're not root user and they don't have to be, they can't write to the file system, it's going to be pretty hard for someone to change your source code or to hack stuff. But most people don't go to this level. So it's nice that there's this guide that will give you that. In case you're new to the security stuff, I have a URL. It's brett.show/security first. And that will take you to my AMA, where I kind of give you top 10, maybe it's even more than that now. It's actually more than 10. I think I'm up to 13. And this isn't even yet getting into Kubernetes and PSPs and stuff like that. This is more about your Docker file, the way you use Docker, and the way you set up your container runtime engine. Speaking of that, we recently had Kubernetes 122 come out. And one of the new things is we're finally, years later, we're getting this option. It's granted it's alpha, so it's not enabled by default, but we're getting this option to set up seccomp policies by default for a cluster, which in my opinion, that should have been a day one feature because Docker had it. When you run Docker run, it's enabling seccomp and AppArmor and other things that security feature features in the kernel. It's setting all these things up. Right? It doesn't necessarily enable SE Linux by default because you got to have that installed. Same with AppArmor. But seccomp is in most places, and it will enable that by default using a default profile that works for most apps. What this is all about is that if you take the same app you're running on your host and you run it in a Docker container, now that seccomp's enabled and other stuff's enabled, it's going to be safer. It's going to have less privileges, and it will protect your server better than if you weren't in Docker. However, Kubernetes wasn't enabling this by default. You could still do it, but it was some work and you had to set it on each pod and it depended on your runtime. And so they're getting now they're sort of catching up with Docker in this way. They're catching up with this feature. And I'm a fan because if you don't set up this stuff by default, nobody's going to do it. That's my opinion. Like we all have this bad habit of we just take things for granted and we all just set stuff up as default. We don't necessarily enable additional security features because we get too busy. And so anyway, this is coming. It's only alpha now, but maybe in 123, 124, we'll start to see this coming as default. And it would be great if Kubernetes would say, oh, you're running container D. Container D comes with a default seccomp profile. Let me enable that for all containers by default so that you're more secure out of the box. Wouldn't that be nice? One can hope. So this is largely going to be depending on your distribution. So if you're running a distribution, you should look into that. And you can enable it today on each of your pods. You can do this now. But it does take a little bit of research and a little bit of work. But this is a thing that I would honestly feel like needs to just be turned on everywhere. Because if it runs with Docker, these seccomp profiles work. And they're not not all these profiles are the same. I get it. There's a little bit of variance. But 99% of the time, it's just not an issue. It just works. And when it doesn't work because your apps usually crash immediately or won't even start, or, and it's usually something like old version of MySQL or some Oracle thing or whatever. It's usually something like that. So. All right, let's see what we got here. As Docker did not fit the new features of Kubernetes, do you think that Docker will be obsolete? I don't see that happening. You still, a vast majority of the world's Kubernetes clusters are still running Docker. Docker doesn't need to implement the features of Kubernetes. This is the point here, is that Docker is shifting to be a developer tool primarily. And then if you still want it to be, it can also be the runtime under Kubernetes. But Kubernetes implements all the features that Docker doesn't need to have anymore because they're now in Kubernetes. So there's no real reason for them to compete because they've always been complementary. Kubernetes on day one was designed to run on top of Docker. That's when they launched the Kubernetes project. That's what it did. So Docker, the company, is refocusing all of their tooling for us on our local machines. And if you've ever tried to develop locally in Kubernetes compared to Compose, you probably had a much easier time in Compose. I personally love Compose. I still find it difficult to do the same things that I do in Compose with the same easy command line to do that in Kubernetes, right? Sure, there are other tools out there, Scaffold and other things. A lot of these are designed around running remote clusters so that you can develop against those. And there are some niche tools that allow you to run Kubernetes locally and then present a similar workflow to Docker Compose. But why not just use Docker Compose? Like, it comes out of the box with Docker. It's very low CPU resource utilization compared to Kubernetes. So for most people, I still advise Docker and Docker Compose for local development use, local utilities, all that sort of thing. And then Kubernetes, again, the Kubernetes project, the original maintainers, and still currently today, it's not designed out of the box to run for local development. It's not easy to use. It's not using minimal CPU resources. And we have all these variants like K3s and stuff like that. But so there's these side projects that try to make it fit that round peg in a square hole. However, Docker is designed for that local developer workflow. If you're interested more, by the way, on Docker Compose and the new features of V2, you can go back in this channel, this YouTube channel, and I have a whole video on Compose V2 and all the new features that make it better for local development. If you're interested more in that too, in a couple of weeks, on the 31st, on Tuesday the 31st, I'm going to be on Raw Code's channel. If you look up Raw Code here on YouTube, RAWKODE, I'm going to be on Raw Code's channel, and we're going to be talking about Compose V2 as well. So you can come check that out over there. If you're on my Patreon, you'll get a notification that that's going to happen. Great question, though. Thank you, Bruno. That was a good one. Yeah, thank you, Artem, for pointing out some of the deprecated stuff happening in Kubernetes. And this just goes to the whole point of, like, things are moving fast. Even when we think things are moving slower in Kubernetes, a lot of the extra stuff on top of it is still changing. And I'm glad you pointed that out. I didn't actually go through that whole guide yet to see if they're talking about other, basically, controllers that will gate your changes. And most of us that maybe are new into Kubernetes, we haven't dived into the whole world of oh my goodness, I'm forgetting the thing now I'm getting ready to talk about. What are they called? Authorization controllers? My mind isn't working at this moment. I actually have a tab up open on this stuff, I think. Admission controllers, that's what I'm thinking of. And admission controllers used to be problematic and had some side effects, and now they're getting better. So I think we've got stuff for today, and then we've got stuff that you're going to have to learn for the future. And that's a good point there. By the way, I have up on my screen, just as a reminder, and an unfortunate side effect of Kubernetes releases is now that we have 122 out, that now means that if we're on any of these older versions, like even 119, which just came out last year, is already headed towards end of life. So we've got a slower pacing of releases now. Yay, that's a good thing. But it's still challenging for those of us that are managing our own clusters. This is why I'm always advocating for outsource that. Let the cloud do it. You know, hopefully the cloud upgrades always work for you. But it's a lot of work to keep these things up to date. And it also is even challenging for those of us that are running different versions of different clusters. And then you've got to have your command line tooling, and your command line tooling may not work with different versions. So it could get quite problematic. And that's why I end up having to run my kube control commands from inside of containers, because I need specific versions for specific versions of Kubernetes. But just to be aware, things are ticking. Tick-tock 118, which I just released a course a year and a half ago that was designed on 118, is now completely out of date. Not that the course isn't completely out of date, but I need to update some of the things, some of the commands in the course, because these things no longer will work with the latest versions of the command lines. Would you recommend Kubernetes or Docker or Swarm for production systems? I think at this point I would always recommend Kubernetes. When you say production systems, I assume you mean a business. And a business should be now relying on Kubernetes. It's going to be hard not only to get all of your add-ons and your other third-party tools to work with Swarm at this point, but it's also going to be hard to hire talent that knows Swarm, right? Because everyone in the industry is now just learning Kubernetes. So even though I still think Swarm is a great tool for simple little workloads, and I still use it myself, I don't recommend that for business production use anymore. Not because it won't work, just because it's going to be more work nowadays than getting an AWS Fargate running and then using all of the extra tools on top of it that just automate things and make it easy to run a Kubernetes cluster. That wasn't true 3 years ago, you know? So things are changing quickly. Let's see. Basically asking, besides bind mounts, can a large several gigabyte file be accessed in an image build? Currently, the file is read into the image and the size is 17 gig. You might not store that file. So it all depends. This is very context specific on large images and files and images. If it's a single file, or is it, you said several gigabit files. So it just really depends. My customers deploy 3 and 4 gig images all the time. Like the image total is 3 to 4 gig, no problems, right? They have a bunch of different layers. They're using apt, they're using npm, they're using, you know, gem files or Maven, Java stuff. Like they're doing all this different stuff, right? So they've got huge images, and that's fine. It is what it is. If that file is changing constantly, it might be worth looking at some sort of other distribution method, like maybe S3, where it downloads when it needs it. I don't know. It really depends on the app. I tend to be a fan of all artifacts go in a image. And if it's indeed an artifact, then it should be stored in the image. But I don't know what's in there, and I don't know the use case for when exactly that file gets updated, how many places does that file need to exist, you know, that kind of stuff. So it's hard to answer that question. Biker is asking, don't Docker and Kubernetes come together as containerd or whatever is the process manager for your OS? I'm not sure what you mean, Biker. Containerd is a runtime and replaces the Docker daemon inside of Kubernetes. So Kubernetes always needs a container runtime, and there's 3 to choose from. There's Dockerd, there's Containerd, and then there's Cryo. And Cryo is largely just used in the OpenShift community, and it's designed only for use with Kubernetes. Containerd is a little more universal, and it's also now used by Docker itself as well as Kubernetes. And it can do all sorts of fancy things. It can do things like encrypt your images. It can control virtual machines. It can do lots of neat stuff. And then there's the traditional Docker solution, which if those of you had heard that Docker had been deprecated, that's not actually true. It's the Docker shim that was deprecated. And then the week after that was announced that basically Kubernetes was no longer going to maintain the shim, which is this little layer in between Kubernetes and Docker. Mirantis, a partner of Docker, said they'd pick up the maintenance. So now they have their own Docker shim that you can use and just keep using Docker forever. And a lot of people like to do this because Containerd and other tooling doesn't build images. Kubernetes doesn't build images, but Docker does. So a lot of people like to use Kubernetes for their CI solution, maybe for Jenkins or something. And so they'll often want Docker underneath so that they can do Docker builds in that Kubernetes cluster. And so then that's what this new Docker shim is for. So if you just look up Mirantis Docker shim, you'll find basically the repo that will give you instructions on how to use Docker, the updated shim, and Kubernetes together. So. Is there a tool similar to Conan for CPP, but for image development and management? I don't know what that is, so maybe someone in chat does. All right, let's see what else we got to talk about. I mentioned all these new features with Kubernetes 122. The things that I really care about: server-side apply, which is kind of fancy, and I'm not sure that everyone really needs it. But it's a pretty cool feature that allows you to basically ensure that you don't accidentally overwrite settings that you didn't mean to change. So your manifest, when you apply it, there's a bunch of defaults. And so you usually only write a manifest file to change away from the defaults, right? If every one of our manifests had to have every value, they'd all be, 1,000 lines for every manifest. But there's defaults. There's these default settings, right, inside of Kubernetes for each one of the resources. And server-side apply tries to help ensure that if you use, the kube control command line to apply a manifest, that you don't accidentally change something in a resource that was updated by another tool that is used somewhere else against that same resource. My thought process on that is that it's probably better for you to simplify your workflow and to use a GitOps tool like Flux or Argo CD, and then make that tool the only tool that's allowed to update your cluster. And that way, you hopefully won't need this. You won't step on your toes because you're only deploying changes one way through Flux or Argo. Some of the other nice enhancements there, but these two are the two that I really got excited about. So the seccomp I already mentioned, and then kubeadmin making it possible now to run even more of the cluster features non-admin, so a non-root user. And eventually, we're going to get to the point where Kubernetes, if you have a modern distribution of Linux, that's key because you got to have a modern kernel. Not all Linux distributions all have the latest kernels to support things like V2, C groups, and some of the necessary kernel features to support this. But if you do, then eventually we're going to have it to where you can run everything in your cluster and all the features work. That's key because not everything always works with a non-root user, which if your runtime is not running as root user, which Docker now does that, right? Docker now can run rootless. And then your Kubernetes control plane can run rootless. And then all of your container images are designed to run as non-root. Then you might possibly have an entire solution that's across the board, nothing running as root, in or out of the container, which is which, traditionally is not possible because there's a lot of things that happen, including networking and other things inside of making containers that required root to do, which is why forever Docker has required root in order to manage the C groups and namespaces and the networking virtual interfaces and all the things that it does. That Linux just required it to have root. But over the last few years, because of the rise of containers, then Linux, the kernel in there, it started adding new features, including a big one called cgroups v2, that starts to allow us to do some of those things that we couldn't do before as non-root. We can now do. So you're seeing Kubernetes enable that functionality as well as Docker. If you're interested in Docker rootless, you could just Google Docker rootless, and you'll see a page on Docker's website how to run Docker daemon on a Linux server in a non-root user, which is pretty neat. It does have some limits, specifically in Swarm. It can't do everything in Swarm with networking because some of those features require root. But if you're able to fit within there, then you could technically run Docker as non-root. And now we're seeing that in Kubernetes. And there have been some attempts in Kubernetes with certain distributions to do certain things as non-root. But it's always been hit or miss. And it's always been there's always been limits to what you could do. And certain things wouldn't work, or certain networking add-ons would not function and stuff like that. So expect to see more in that world. All right. So I want to talk about the AMA. I'm going to check chat real quick, but I'm going to want to jump into this AMA discussion about my AMA. You can go there, by the way, anytime by going to Bret.show/AMA or just probably searching for Bret Fisher AMA. So it's a GitHub repo. And it used to be issues, but just today I converted all the issues over to discussions so we could get, it's a little bit better as discussions, and I can mark things as answers, and that'll help us. But you'll see I've got pages and pages of people asking questions around Docker and Kubernetes and DevOps, architecture design, security, networking, like you name it. I've got at least, I think, 3 years now of people asking questions in there. And most of them have answers. Unfortunately, it's not letting me mark things as answer. I think there's some sort of bug in GitHub right now because I can't mark things as answers, as being answered. But I want to go through some of those questions that have come up recently. People have asked questions, and I want to go through them with you and share some of the answers. Finn says, how do I donate? Loving the stream. You can use Super Chat, which is a YouTube feature. So you can do Super Chat inside of YouTube. Or you can go to my Patreon page. Thank you for asking. So you can go to patreon.com/Bret Fisher. You can go down below and you can become a member for a few dollars a month and get benefits, extra benefits. And I always appreciate anyone willing to give a little of their hard-earned cash to support this live stream. All right, let's go back to our discussions over here. Yeah, that's a great point, Biker, about all this tooling is designed to work together. There's now standards that govern a lot of the things in the container world. And if you can build your images with whatever tool that will support an OCI standard image. And then you can run that on any tool that supports running an OCI standard image. So it's nice, right? All right. So in my AMA, I'm going to throw down some questions that have come in this year that I think are worth talking about. And this one right here is about basically the architecture of your proxies. Now, if you deployed Kubernetes in a real production environment, one of the jokes is it's proxies all the way down, that there's proxies everywhere, and that you're now going to have to deal with multiple levels of proxies. And that's just life. Right, we're to the point when you're talking about an HTTP protocol, you end up with front end and you maybe even have app-based ones. You might even have a service mesh that adds even more layers, possibly one to every single pod or one to every single node, depending on your design. And so you end up with potentially 3 to 4 levels of proxying. And if you're using CloudFront or something like that, you got another proxy in front of it. Like there's just tons of these proxies, right? And it's tough because it adds complexity, but it's also solving a lot of the inherent problems we had with things like adding TLS certificates into your app. Well, we don't really do that anymore. We don't put certificates in the app themselves. We have a whole set of proxy tools that automate that for us. And so this person was asking about, they've got a Flask app, so they're using Python, and they need to run that with Nginx. And should they make that also their proxy inside of their cluster? And that's a great question. My answer is basically no. You should separate these things out, and that you probably will have a cluster architecture where you have a set of proxies, and now we call these ingress proxies. So the ingress is at the edge of your cluster. And maybe you're using the cloud to do that. Maybe you're putting it in the cluster itself. Maybe you're using Traffic, Nginx. Maybe you're using Envoy with Contour. There's lots of options there. And so that is a universal data plane of ingress resources, and it serves all your pods and all of your services. And then you might have specific apps that need to run in Nginx. But don't necessarily think of that as I don't need an Nginx in my app because I've got this other ingress, right? Don't think of it like that. You think of it as, well, my app always has to have Nginx to run. Maybe it's because if you're in PHP and you're using PHP FPM, for example, that usually needs Nginx in front of it, or Apache, but I prefer Nginx. And so you're going to bundle those together. And so maybe in the pod, you're going to have one container for Nginx and one container for your PHP FPM, or in this case, they're using Gunicorn, and they want something in front of it. So those right there, they're always shipped together. You want that design because that way you don't have to have that specific ingress you have in that particular cluster, right? You want to design those together so that it'll work in Compose, it'll work in regular Docker, it'll work in any Kubernetes cluster that you throw it at. And then your ingress, which is this thing that's maybe using the cloud-provided ingress, maybe in your data center it's using Traffic. And that's a separate concern that has a separate config file that's not related to your app. And this is a part of distributed design. So when we start talking about distributed systems design, you want these different pieces to not be tightly coupled. We want them to be loosely coupled. So that way I can change my ingress without having to worry about the app supporting it, right? Because ingress is a separate concern. Or maybe my app, I want to shift from Nginx to some other thing. Maybe I want to go from Apache to Nginx, or Nginx to some other new high-tech web server. Maybe you want to do that. And you don't want to have to tell the ingress people that they have to change their ingress because you're changing your app, right? You don't want to do that. So that's how you design these things to be loosely coupled. So that was that one. Next one up, I thought was a really similar question, by the way. I'm not going to go through this one because it's a very similar question. But really the question, which was just asked yesterday, was about, they have an Nginx front-end proxy. Then they want to use Varnish for their PHP app. And then because it's a PHP app, they need Nginx for the PHP app. And in that architecture, you might think, well, because I'm using Nginx twice, maybe I can just use the same container to do both. But that would be a bad design because it's not as flexible. Again, you don't want to tightly couple your app to a specific ingress for the entire cluster. So in his case, or their case, they're going to have that Nginx that's for the whole cluster maybe, and then they're going to have this Varnish that's just for his app. And then that Varnish is going to talk to Nginx and then the PHP FPM. Now, the Varnish, Nginx, PHP FPM technically is probably 3 containers. But you can make those 3 containers work in Compose, work in Docker, work in Swarm, work in Kubernetes. You can make it work everywhere. And then that front-end Nginx, the one that they have listed here, right? That one has the SSL certificate and it sits, at the front of the cluster and it's automated in an ingress type fashion. And maybe if you're running in the cloud, you don't even need this one anymore because maybe the cloud provides that for you. So you can throw that part out and you can just run your app parts. All right. Anyway, that's a distributed cloud native design model for traffic like that. I'm going to throw out the Swarm 2021 thing. You've already heard me talk about this on the show, but I'm just going to throw that link in there as a reference. I basically say the same thing, that, yeah, it still works and it's great for hobby projects and small things, but if you're doing business, you're probably going to want to run Kubernetes because that's what everyone's learning. That's where you're going to hire new talent. New talent's going to know Kubernetes more likely than they're going to know Swarm. And then you're going to find way more of your tools support Kubernetes out of the box than Swarm, right? Very few tools now support Swarm. They kind of all gave up on it years ago. So you might have more work to do to get things working in Swarm, whereas maybe your tool of choice might just have a plugin for Kubernetes and it works automatically. And then the last one I have here is, why would I consider Compose over a tool like Minikube for local development? So I give you a bunch of reasons. I have a nice little post there that goes through all the details and advantages of why you would use Compose. And one of the things that I often find with people in Docker Compose is that they don't realize all the things it can do. And so they don't even realize how powerful it can be for local development because they're used to doing other commands. Like maybe they think they need to use a Docker exec command. But that wouldn't be what you do. You use a Docker compose exec command, or a Docker compose top, or a Docker compose restart. So there's all of those commands you use Docker are now replaced by Docker compose commands that are better because they're more focused on just the project you're in, just the directory that you're typing the command in. And so you could potentially have a bunch of other containers running, and when you use Docker compose commands, it will only concern itself with the ones in your current directory and the ones in your compose file. Whereas Docker commands don't, right? So if you do a Docker command, Docker PS, the Docker PS command is going to show you everything on your whole system. And maybe you only care about the ones in your current project. And so that's why Compose is the way it is. It's really designed around a developer workflow, project-based workflow, running in a single directory. All right. Any more questions? I'll give you a minute to think about it. All right. Well, thank you so much for showing up. I'm here every week. Next week, I have a guest. Nigel Poulton is on the show next week. My friend Nigel, who's also a Docker captain and a Kubernetes expert who teaches Kubernetes in the real world and on the internet. So we have a lot in common, and we met as Docker captains years ago. I'm having him on the show next week. We're going to be talking all about his books, his courses, his skill set, and we're just going to be talking Kubernetes mostly. So show up at the same time next week. And then after that, we've got guests coming in the future weeks after that in September. And the way that you learn about those guests and to know what's happening on there is to go to Patreon. So I'll just mention it one last time. Go to the Patreon page, patreon.com/Bret Fisher. Sign up for that. You'll get like one email a week. It'll let you know what's happening. That email's totally free. All you got to do is scroll down and click the follow button and sign up for an account. And you don't have to pay to get that stuff. And yeah. Although we do have a couple of last minutes questions, so I will quickly answer these and then we'll wrap it up. Sandir asks, is there a way to categorize images? No. Tags are really, you have repos and you have tags. That's about it. If you're using Harbor has the idea of projects, which is technically kind of like a category, but no. Now, remember, you can always tag things with many different tags, right? So if you wanted to create categories, maybe having there's nothing wrong with having a single image that you tagged with 10 different things. Now, unfortunately, tags don't allow you to have multiple images with the same tag. That wouldn't work. So there really isn't any way to categorize it. When you're on Harbor, you can make projects, and then you make repos in those projects, and then you make tags in those repos. So you have in Docker Hub, that's kind of like creating a new organization. So think of the organization as a project. But yeah, we don't really have projects or categories or anything like that in Docker Hub. Vaughn asks about secrets. Are secrets used only for development? Are they stored in run secrets? Is that a security risk? Should the file be removed after the container is started or change the permissions? It seems odd to me that sensitive data is stored as a plain text file. So I talk about this actually in my AMA. So let me go find that one for you instead of repeating it all. So if I go to category, actually, no, it's not category, it's tag. Does that work? Tag security? Oh. I know there's a question. Is Docker secrets actually used in production? So I'm going to post this in here for you. Maybe go check out some of those answers. I bet you they will answer your question. I guess the point about secrets is that information has to be stored somewhere. And your app, unless you custom build an app with a decryption key, it's not going to be able to decrypt anything. And then where does the decryption key get stored, right? So like at some point, your app has to have something somewhere to get the secret information. The reason that secrets are considered as secure as we can make them is because when they're stored at rest, which means on permanent disk, they're always encrypted. When they're put into the container, they're on a temp FS. So they're inside of memory, not on disk. So they're technically in the container as a clear text file, because otherwise, how would your app be able to read them, right? Now, there are things like Vault where you can get one-time keys and stuff like that, or rotating keys, but your app has to be specifically designed for that, where it's and the thing that you're using has to be designed to specifically get updated passwords all the time. So you can do that, but that's very application specific. And then again, in order for your app to talk to Vault, it's going to need a secret in order to authenticate. So that secret has to be stored somewhere in plain text for the app to get it. And you know, because it's in memory, it's about as safe as we can get it. So you get this whole problem of initially your app has to get it, and your app's going to store that secret in memory. So if someone gets in there and they can, and remember that a lot of these directories are root only, or they're not changeable and stuff like that. So there's a lot of other protections and put in place to keep things from changing on the fly. But the reality is, if someone gets in your container and they have root access in the container, they can just look in memory and see the secret in memory. So it's one of those things where there's only so many levels of protection you can provide before what I would say is the effort involved with making it that one step more secure is more effort than necessary to protect your app from 99.9% of all things, right? I would say it's very rare for me to even go into a company and see them at the level of always storing all secrets as files. One of the features that Docker and Kubernetes can do is they can store secrets in environment variables. And the reason that tends to be a bad idea is because those will often show up in debug screens or in logs where you don't intend your secrets to go. So I think for you, one of the best things you can do is for all of your apps, you get your secrets into Docker Swarm secrets or into Kubernetes secrets. So that way they're never written to disk unencrypted. And then you don't use them in environment variables. You basically design your apps to go pick up those secrets when they start up in the file. They don't go looking to environment variables, because that way you can't just go simple env to list all the secrets, right? You can do an env dump. And a lot of other apps like PHP info, right? It will dump all environment variables, stuff like that. So those are common hacks for people that are not dealing with secure applications to find out your secrets. But if your secrets are only stored in files in that special secrets place, they're only in tempfs, and then they're not env based, they're file based. That's just about as secure as you can get. The next layer up for more security is to only put your secrets in Vault, and then have those secrets rotated so that your app picks them up once, and then the one in Vault changes, and the next time that it gets it, it's going to get a different one. So that's another layer of security. But honestly, at that, there's very few teams that are that advanced for all the things, right? Like a lot of apps don't support that. So I wouldn't say that that's required. I would say do all the other things first, right? You go to my security list, because on my security first list here, I am specifically, in this security list, I specifically order them in the biggest bang for the buck first, right? That's why number one is just use Docker or Kubernetes. If you just do that, you're already going to be in a better security posture than if you were running your apps on the raw host machine, all right? And then it starts going down the list, right? Scan your hosts before, with the Docker bench tool to make sure they're properly configured. Kubernetes has the same thing. It has a scanning tool called SonarBuoy. If you use SonarBuoy for Kubernetes will help you ensure that your design is secure. And then do things like don't expose sockets when you don't need to. Don't run things in your app containers as root, which a ton of people do because it does it by default. And then you go down this list, right? Make sure you're doing dependency scanning inside of your images. And so eventually you get down to things like use Vault and rotating secrets, right? Because that's that's not as low hanging a fruit as a lot of these things in this list. All right. Hope that helps. Oh, it seems we've got even more questions. Hisham asks, Swarm production in the Azure portal. No, I do not have a course on that. And at this point, if you're going to deploy on Azure, I'd probably recommend just using Azure Kubernetes. Otherwise, you're going to have to roll your own Swarm versus using something they provide. And anything that the cloud provides is going to be more secure typically than what we design ourselves. We don't have entire teams of people locking things down like they do. So I generally advise use the cloud provided when possible. GitHub also has teams within organizations which can have access rights to repos, so limit the visibility. Good tips, good tips. How do I track? Razvan asks, can you walk us through a bit on how to track tasks on a Docker-based project with Git, Docker, Azure DevOps, basically the way of working setup? Sorry if it's too random. We just started using Docker and we're not sure how we're going to track tasks from dev to UAT to prod. Well, I'm not an Azure DevOps person, so I can't help you there specifically, but you're basically going to want to put everything in a Git repo, not necessarily in a single repo, but your Docker files should be stored with your code. And then on every commit in a PR, you're going to build your images and ideally test them inside of your CI. So you're testing inside the images you're testing. And then you're doing functional testing, stuff like that with the container and the database and all that stuff. Maybe you're using the tools of your CI, maybe you're using Docker Compose inside your CI, but you're doing all that. And that's all automated. You're building every time in your CI, every commit inside of your PR, at least every commit in your PRs. Maybe not every commit in random branches, but every commit inside of your main branch or your master branch and your PR branches. You should just be building those and testing those every time so that everything's always deployable. Everything's always tested. And then you're going to have other repos for maybe your Terraform that's storing your Terraform infrastructure. Maybe you're looking into GitOps, which is how to deploy those images and either your Helm charts or your Kubernetes manifests. You're going to deploy those with something like Flux or Argo, and that is stored as YAML inside of another repo so that every time that repo changes, maybe you're changing the version of the image. And then you change that, you do the PR process like normal, and when that's approved, that will then update your production infrastructure or your staging or whatever with those new images or the new settings or whatever you changed inside the manifests. All right. So from the developer's point of view, they change code, it's auto built, auto tested, and then when they're ready to ship that to production, they're merging that PR of code And then someone's going to change the DevOps repos, right? They're going to go change either the Helm chart or the Kubernetes manifest, and possibly even the Flux and Argo stuff, depending on how you have those set up. So you're basically, the only things you're touching to deploy a new version of code is repos. You're doing 2, 3, 4 PRs, depending on how much you break this out. And it's not just code anymore. It's now the infrastructure in in those repos as well. So that's how I would do it. And the rest of it, it gets very specific and nuanced to your specific setup and your team and the way that you like to work and how you build your infrastructure and what tools you're using. That all varies. But hopefully that gives you some idea of how to design it. All right. Rabble says, deploy cert on container deploy and use cert to initial auth with Vault. Sure, you could do that. You can do that. I mean, fundamentally, the point there is that your container is always going to have something in it that's a decrypted key of some sort sitting on, hopefully, a temp file system that's not written to disk, that has access, has a secret. And then, so there's always going to be something somewhere, right, inside of your container. But if you do all the other things that I listed in my security list, things like not running as root in the container, all the other rules and stuff above that, then it's going to be that much harder for anyone to ever get on the disk to be able to read those files. It's going to be quite tough for them to do that. So anyway. Charlie's saying, Brett, to be clear, I thought you might be surprised, dismayed also by what I shared, how those GitHub answers you offer are not findable via Google. Wouldn't that have been your hope? I mean, I just did it today. So, I mean, they were all issues, and now they're discussions. So, I mean, they're still issues. They were all closed issues, actually. So I'm just assuming that maybe that needs to be indexed. I don't know. I'm not really sure. I've never really searched for my own answers inside of Google. But hey, as long as you remember there's an AMA, you can go search it, right? But I don't really know in terms of like the search ranking of GitHub issues and GitHub discussions. So yeah, hopefully they're still searchable, and that yeah. But I mean, I did it like the hour before the show because I wanted to try out discussions, and they look pretty cool, and they look a better fit than using GitHub issues to have discussions. So there's a button you can now convert. You can convert all issues to discussions, and I did that for all, I don't know, 100 or 200 of those things. All right, well, thank you everyone for joining. Went a little long today, but we had some great questions. Again, I do this Udemy Q&A specifically for students and for anything about the courses or just continued learning. I do that once a month. We got guests next week. We're having Nigel Poulton on talking about Kubernetes and all of his stuff in the world of Kubernetes and Docker training. And I will see you at the same time here next week on YouTube Live. Ciao, everybody.